This one you have to do the chain rule. So when you take the derivative, you go term by term, right? So when I go to find the derivative of this, I'm going to take the derivative of the first term. I see that I have something squared, taking the tangent of something, and then I have the pi x, right? So I'm going to take 3 derivatives in this first term. Does that make sense? So the first thing I'm going to do is write the proper notation, because that's half a point on every single question of the test. You don't want to lose those 7.5 points, yes? So then I take 2 times the 4, and I make this 8. Tangent, reduce that power by 1, so now it becomes the first power. Everything else stays exactly the same. Now the next outermost function I have is a tangent, so I take the derivative of tangent, which is secant squared, and I leave that pi x alone. And then I take the derivative of the pi x, which is just pi. Now going to take the derivative of the second term of this plus 8x squared, that's going to be 16x. And I would probably, at the very least, maybe bring that pi up in front so I don't forget it. And then tangent pi x secant squared pi x plus 16x. If you factored out an 8 from those two terms, that's fine. If you didn't factor out the 8, that's okay. Good? You could, you don't have to, but you could make the sine of pi x over cosine cubed pi x, but you don't have to. Not in this class. Yes. No. So once I did this, when I took the derivative of this 8 and this 2 and I made this 8, that took care of the something being raised to the second power. So then I just go in and take the derivative of just tangent. So now I'm taking the derivative of just tangent, which is the secant squared. And then you copy everything down, and then the last thing is taking the derivative of that pi x, which is that pi. Well, does that matter? Does that make sense? Okay, this one, I am going to use the chain rule. You could have, if you wanted to, you could have like squared the 2x plus 1, squared it, and then you wouldn't have to do that. Does that make sense? And I don't think anyone would have taken that and then raised it to the third power. That would be silly. Like, don't do that. So if I'm using the chain rule, the outermost function I have is this being raised to the third power. So I am going to do 3, and when I do this, I'm going to leave everything exactly the way it is and reduce the power by 1, so now this is squared. Then I go inside, and I'm going to take the derivative of this 2x plus 1 squared, so that's going to use the chain rule again, so I'm going to take this 2 and multiply it by that 2x plus 1, reduce the power by 1, so that's now going to be 1. Take the derivative of what's inside, which is 2. And then the derivative of this 5 is just 0, so plus 0, don't have to write it. Then what I have is everything's being multiplied, but I have this 3, the 2, and the 2, so that's going to end up being 12. And then 2x plus 1 squared plus 5 squared times 2x plus 1. You cannot FOIL that in. You have to leave it outside because this is raised to the second power. And that's all you can do. You leave it like that. Yes?
Is it okay to simplify the inside of the middle one?
Yeah, so you could have, like, yes, you made this 4x squared plus 4x plus 1, and then add the 5, so 6. Yeah, but, and oh, is that your 2 that you have?
That's what I did, but then I forgot it was squared.
Yeah, you have to square it, but I wouldn't bother wasting my energy on that. Yes?
On the quiz, or on the test, is it going to be like the quiz where you just tell us to find the derivative?
Yes.
Okay.
So, like, literally the directions from 1 through 10 is find the derivative.
Okay.
And I'm not telling you you have to use the product rule, the quotient rule, the chain rule. You need to know that. Any questions on this? Any questions on the homework? Alexa? Oh, wrong page. Is that the word problem?
Yes.
So you have that function. It says the frequency of the fire truck siren is observed where the plus or minus v represents the velocity of the accelerating fire truck. In meters per second, find the rate of change of f with respect to v. So when they want you to find the rate of change, they're asking you to find the derivative, right? So they want you to find the derivative. It says the fire truck is approaching at a velocity of 30 meters per second, use negative v. So they want you to put in, so they want this f to equal, and then this is 331, and they're telling you to use negative v, so I'm going to put negative 30 in here. Yes? I feel like I need a variable. The fire truck is approaching at a velocity of negative, where v is a velocity. Oh, you are so right. You do. So, negative v. Now I take the derivative. I want to put a v here. Can I put a v there? I'm doing it. You can't stop me. So 331 minus v. Leave my denominator alone. Take the derivative of my number. Oh, pause for a second. I can do this a different way now that I know the chain rule. Do you want me to stick with the quotient rule, or you want me to show the way with the chain? The other way would be if I take this 132, 400, and I make this quantity of 331 minus v, and I raise it to the negative 1. So much easier. Caitlin? Yeah. So can I do it that way? Blue? I took this, since it's in the denominator, I brought it to the numerator and raised it to the negative 1. Now when I'm going to take the derivative, I'm going to take negative 1 times this, so this will be negative. And then 331 minus v, take 1 away from this power, so negative 1 minus 1 will be negative 2. And then take the derivative of what's inside here, which will be negative 1. Which gets, yeah, makes it positive. So then this will end up being, I'm going to, negative times a negative makes it positive, and since this is a negative exponent, I'm going to put it in the denominator. Well, I'm done with finding the derivative, and then it wants the 30 meters, so then I'm going to put 30 in and get an answer. Yes, and my calculator will do that for me. I don't need to do that. Yes. And then part B says the fire truck is moving away, so use the velocity. So then I'm going to use this other one. So basically the same thing, except for this is going to be a plus sign. And then it's going to be a negative on top. Yes. Because they don't have that negative 1 derivative. Yes, ma'am?
I was just wondering, do we have to put the, like, in parentheses, like, V or T, or can we just do, like, the little thing on the top? Like F prime, can we just put that, or do we have to have the parentheses?
Oh, with the T, the F prime sign. Alex? 86. Oh, this is the one I did not like. Okay, I'm going to start way over here. Yeah. Yes. 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 We do, but I kept them to sine and cosines and simple ones. Okay. So when I do so it's raised to the second power, yes? So I'm going to do 2 secant, reduce the power by 1, so it'll just be 1, and then this is pi x. And then the derivative of secant is secant times tangent. But you have to leave what's in the parentheses alike, so you just have to write that pi x, right? And then I take the derivative of that pi x, which is pi. So we agree that this first derivative is equal to 2 pi and then secant squared pi x tangent pi x. And that wasn't terrible, right? Now it gets terrible. So I'm going to find the second derivative. So when I find the second derivative, I have this 2 pi. I just left the 2 pi out here, and I'm just going to bring it down with me, okay? Then do we agree? I think we should agree. Maybe we won't, but I think I will. The derivative of secant this, yes? So that's what I have right here. Oh, yeah, that's what I have right here, yes? Do we agree that those are the same? So do we agree that I have to use a product rule, which is going to make this really nasty, but do we agree that I've already done the derivative of that? Yes? And that's that whole line, yes?
So it was, I converted it, I wrote it in terms of sine and cosine and did the quotient rule.
Was that better for you?
I don't know, it's still awful.
Oh, I'll do my way and you'll tell me how awful it is compared to the way you did it. So I'm just copying this down, 2 pi secant squared pi x times the tangent of pi x. That's just me taking the, highlight. That's just me taking the derivative of that, yes? And using the product rule, I took the derivative of the first term. I have to multiply it by the second term. And then I add, leaving the first term alone, so the secant squared pi x, and then take the derivative of tangent x, which is secant squared. I didn't skip any steps. Oh, and I forgot. Oh, my bad. I did that. Oh, no, that's fine. But then here, secant squared, tangent x, secant squared x, and then I have to take the derivative of pi x, which is pi. That's what I almost forgot. Yeah. I agree with myself. I might be wrong. I don't think I am. Everyone with me? No one's with me. Let me try.
Okay, you just short.
I did not skip. Yes, I skipped. I knew what this was because I just did it.
Yes.
So I copied it, which is you guys. That's how you live your lives. You copy, and then so that's a product rule. I took the derivative of the first one, left the second one alone. Yes. Now I'm taking the derivative of tangent of x, which is secant squared x. Yes. And then I leave the other one alone, so I left the secant squared alone, and then I have to take the derivative of what's inside, which is pi. Good? Yeah, I did say they were nasty. I'm so sorry. So, yes, you have to know how to do this, whoever said that. I hate that question. Yes, it's going to be on the test now. Oh, I'm sorry. This? Yeah. I'm live streaming, just like Nestpost. All right. So, do we agree? Maybe we don't. I'm okay. I'm going to write 2 pi, and then this will be secant squared pi x. Yes. And then the tangent times the tangent will be tangent squared. Yes. And then plus, I have this pi here because of him right there. And then the secant times the secant will now be secant to the 4th. That just looks so much better, doesn't it? Oh my gosh, no. Come on, people. I can factor out a pi, and I can factor out a secant squared. Yes? So I am going to make, with the pi that I factor out, will make this 2 pi squared. And then I'm factoring out a secant squared. And then I'm going to be left with, I factored out a pi, just 1 pi. So this is 2 tangent squared pi x. I factored out that pi plus secant squared pi x. I feel like that should equal something. I don't think it does, though. No, it doesn't.
Tangent squared plus secant squared.
No, it's 1 plus tangent squared is equal to secant squared. Huh? Yep. Good? Happy? No.
I said I was kidding.
That is not a joke.
Any other questions?
I know this is like gross and all, like this whole problem.
Graphing that we had before, except for you have to remember the rule for doing a composite function. So I do believe the directions tell you, for 1, we want to find h of 1, and h is f of g of x, right? So I'm going to take the derivative of the outermost function of that g of x, and then I'm going to multiply it by the derivative of g of x. That's the chain rule, yes? So now remember, when I had that tick mark, that means I'm doing the slope of the line. So the first thing I need to do is I need to find g of 1. So this will be f g of 1, and then times, yeah? So now g of 1, here's 1, g of 1 is 1, 2, 3, 4. Do we agree it's 4? Yeah? So this is f prime of 4. times, can we find the slope of g of 1 while we're here? Can we find the slope? And when I found that slope, I think I said 1, 2, 3, 4. So I'm moving 4, rise over run. That's my run. And I'm going down 1, 2, 1, 2, 3. No, that's not right. 1, 2. Oh, it's 2, right? So negative 1/2. Do we agree with negative 1/2? So this is negative 1/2. And then this, oh, no, that's not negative 1/2. Why did you let me write that there? That goes over here, yes? Ah, and now I want to find the slope at 4. So here's 4. So I want to find the slope right here. So for 1, 2, 3? No, 4. So my rise is down 4. Everyone agree? Everyone see what I'm doing? No one knows. 1, 2, 3, 4, 4. So that's negative 1. So negative 1 times negative 1/2. So positive 1/2. And then for the s of 5, I'm going to do the g of f of x and do the same thing except for the other direction.
Yeah.
Okay.
So then how do we answer the next part?
Same thing.
Same thing except for now you're doing g of f of x times f of x.
If the derivative does not exist, explain why.
Where does the derivative not exist?
That's prime of 5.
Really?
Somewhere it doesn't exist.
Really?
Oh yeah, because if you do prime.
So f of 5, 1, 2, 3, 4, 5, f of 5 is 6, right? Oh, it's that sharp turn. Can't do it.
Yeah.
Because you're not approaching the same slope from both directions. Like as I'm approaching here, the slope is 0. As I'm approaching here, it's negative whatever. Yeah, that goes back a ways. Yes, I agree. No, sure, why not? I didn't put a graph on the test, so I'm sorry. So I enjoyed going over this, but it's not on the test. Any other questions? Cassie?
We do 67. I get how you do like the whole first half. I just get lost when you're trying to plug in the y part.
I rewrote this as 3x squared minus 2 to the 1/2 power, yes? And you want to find the equation of the tangent line at the point, so I have to find the derivative to find the slope. So when I find the derivative, this is going to be 1/2 times 3x squared minus 2. Reduce that power by 1, so negative 1/2. Then multiply by the derivative of what's inside here, so that's going to be 6x. Then the 2 and the 6 simplify, yes. So I end up with 3 over 3x, sorry, 3 over 3x squared minus 2 to the 1/2. And then it wants, so this will find the slope of the tangent line. I have the point of on the tangent line. So now I need to find the slope at that 3. So 3 times 3 over 3 times 3 squared minus 2. So that's 27. So that ends up being 5, right? 9/5. So that's your slope.
Right.
I'm a point slope person. Are you slope intercept or point slope?
I'm slope intercept.
Okay, y, which is 5, is equal to m, which is 9/5, x, which is 3, plus b. And so 5 is equal to 27/5 plus b. So b is equal to negative 2/5. Did I do mental math right? Oh, good for me. Y is equal to my slope, which is 9/5 x minus 2/5.
Okay, yeah, so it's exactly like the other one.
Yeah.
Is that real?
Oh, yes. In fact, I think it was a little meaner than that because I think I just gave you the x value and you have to find the y value and then do both. It's fun. It's one extra step which gives you some like little cushion points in there, yeah? Yeah. Yep. Yes, ma'am.
Miss Ward, is the one on the quiz good, or is the one on the test gonna be like this one, or the bottom simplifies? Like with the
Yeah,
with the square root.
Yeah, I think all your slopes are rational numbers. All your slopes are rational numbers.
It's almost as satisfying as the other numbers.
That 0.3 repeating is a rational number.
No, like not like.
So it's not irrational. In other words, your slope's not going to be the square root of 2. Any other questions? Going once, going twice. All right, great. Then I want to do this one. There's some that I want to review before we move on. So the big question I had in last class was, how do I know when to use a chain rule? And then they said anytime you're raising a function to a power, you have to use a chain rule, right? Like this one, if I wanted to find the derivative, I'd have to use a chain rule.
Why though? Can't you just say that 6x plus 5?
Because it's underneath the square root. So technically it's 3x squared plus 5x to the 1/2 power. And then are we good on that one?
Yeah.
Do you want to do that one? Or are we good?
No, we're good.
Okay. I also have to use a chain rule when you have to use a chain rule whenever you have a composite function. So this is me taking the tangent of 3x. So the inside function is that 3x, the outside function is the tangent. So I'd have to use the product rule or the chain rule for this. Secant squared 3x times 3. And I didn't write anything, so let's be all neat and tidy. Yes?
So we use it anytime we raise something to a power and for what?
The chain rules for composite functions. So when you do a function within a function.
So when we simplify that, that's 3 secant squared.
3x, yep. Good. Then we have one like this. Where'd it go? Please tell me I didn't erase it. Oh, so this one was similar to one that was on your test the other day. And then we talked about it earlier. I can do this now with the chain rule instead of the quotient rule. So before you had to use the quotient rule. So now I want you to do this using the chain rule. I'll give you a minute. Sure. All right. So I rewrote this to -1, yes? And then now I'm going to use the chain rule. Notice the notation. When I first did that, I just rewrote it so the f of x stays the same. Yes? Now I'm taking the derivative, multiply by -1, so this becomes a -36. X squared plus 8 stays the same. Reduce this power by 1, so this is now -2. Take the derivative of what's inside here, which will be 2x. So I take the 2x times the -36 and get -72x, and then this x squared plus 8 goes in the denominator. Much, much, much easier than using the quotient rule. Yes? And that only is much easier to use a quotient rule when you just have one term up here. Yes, ma'am?
If I went for like f prime x, so like the, where you rewrote it,
Yeah,
would you like take on
I would.
you would?
I would. Now that's a request from the people above me, Mrs. Pesic, who say that the notation is very important.
Wait, so
Well, Mrs. Kelms has CCP stats,
wait, Miss
mathematically speaking, in this building.
I thought you were
I know
gonna
Miss
say
Page, she's the chair.
wait,
Yeah.
this is arbitrary.
Mrs. Pesic.
Wait, so if it was like this on the top, I couldn't do the chain rule.
You could. Then you'd have to do the product rule.
So if, at that point, it would just be easier to do the quotient rule.
Well, it depends on what you find easier. Do you find the product rule? I think it's easier to simplify using the quotient rule
Yeah.
than the because if you're doing the product rule, you're going to have a negative exponent, and you guys sometimes mess up those negative exponents. Caitlin?
On the test, will we be able to choose whether we
Yeah.
want to use the chain rule?
Yep, your choice. As long as you do it right, your choice.
Exam.
On the exam, yes, your choice.
So the whole time we could just not use the chain rule.
Huh?
The whole time we could just not use the chain rule.
You're gonna have. So if I have one like this, well, if I have something like this. And I raise it to the 15th power, then I'm locking you into the chain rule. So her question was, hello? Her question was, on the test, do I tell you you have to use the chain rule? And I said, no, you don't. I'm not telling you which way to do it. But if I give you something like this and it's raised to the 15th power, there is no way that anyone in here should try and attempt to raise that trinomial to the 15th power. Not worth it. Even with Pascal's triangle, not worth it. And actually, you can't use Pascal's triangle since it's a trinomial, not a binomial. So you have to. There, I'm locking you into the chain rule. Okay? This one, chain rule, very simple. I take 15 times this,
That would take so long to do.
reduce the power by 1, so that's 14. Then take the derivative of what's inside, so that'll be 8x plus 7. I can leave it like that, or I can bring the 8x plus 7 next to the 15. Doesn't matter. I'm done. No. Please don't do that. Because you want to simplify. You want to factor it as much as possible. So by you redistributing that 15, the next person who comes along would have to factor it out. What? Like, if this would have ended up being like 8x plus 8, you can factor out an 8 from that. Yes? All right, then there's another one in here, and I don't know where it went, and I guess I'm just going to have to remember what it was. All right, here we go.
I think I know what she's doing. I did know what she was doing. To the 7th?
It doesn't matter what it's to, people. It doesn't matter. It's just a number. You know, in block 1, I think this was a 5th, this was a 12th, and this was a 19th or something like that. I'm being nicer to you guys. I'm going to give you a minute.
And then what am I multiplying that?
Okay, you have a choice. That raised to the 5th, you can either use a chain rule, or you could raise each power to the power. Which way? I'm going to use a chain rule. So if I use a chain rule, I'm going to have 5 times this x plus 4 to the 3rd over 2x squared plus 4 to the 7th. And now this whole thing is being raised to the 4th power. Now I'm going to take the derivative of what's inside, which means I have to use the quotient rule. So now I'm going to leave the denominator alone. We only have one song to sing while we're doing this. You guys are slackers. And then the derivative of this would be 3. Reduce that power by 1, so this is now squared. And taking the derivative of x plus 4 is just 1. So I could write times 1, but I really don't want to, so I'm not going to. Then I'm going to do minus. Now I'm leaving that x plus 4 to the 3rd alone. Taking the derivative of the denominator, so that's going to be, I'm going to write here 7. Then 2x squared plus 4 raised to what power? 6. And then multiply it by the derivative of what's inside, which would be 4x. And this is going to be all over my denominator, which is going to be that 2x squared plus 4 squared. Good? Oh, I lied to you. It's the 7th squared. Oh, I almost made a boo-boo. Good? 20 times 4? 80?
Thank you. I don't have my calculator on.
Wait, why did you square it and square it again?
So,
Huh? Because my denominator is 2x squared plus 4 raised to the 7th. And then I have to square that denominator, so now it's going to end up being to the 14th, right? But when I go to write this, I put the 5 in the numerator, this 5 here, yes. I'm going to write this as x plus 4 to what power? The 12th. Everyone good with that? Because I'm raising the 3rd power to the 4th power, so that would be to the 12th. And then I'm going to put this all over 2x squared plus 4 to the 28th. And then here's this times. And now I'm going to clean that up a little bit. Can I clean that up a little bit?
Yeah, wouldn't it be like what, negative 12x?
oh yeah, I cleaned it up.
Or
I'm going to have a 3. 2x squared plus 4 to the 7th, x plus 4 squared, yes?
What about the 4x?
I feel like everyone's yelling, minus, I'm going to do it. 2x squared plus 4 to the 6th, x plus 4 to the 3rd, and then that 7 times 4x would be 28x. All right, I'll do it. 28x. All over 2x squared plus 4 to the 14th. There's a parenthesis over there. Are we happy? The numbers aren't nearly as obnoxious.
That's helpful.
Well, I'm just copying it. She's I don't actually know how to do this.
Oh no. No. Fine. I can do that.
I have a 2x squared plus 4, 1's raised to the 6th, 1's raised to the 7th, so I'm going to factor out a 2x squared plus 4 to the 6th because that's the lowest power.
Wait, where did it go?
And then I have an x plus 4 squared and x plus 4 to the 3rd, so x plus 4 squared is the lowest power. And then I'm going to multiply that. I got brackets and brackets and brackets. Here's that 3. I factored out the x plus 4 squared. I factored out this 2x squared plus 4 to the 6th. I have to the 7th, so I have one of those left over. And here's this minus.
I have something to the 42nd power.
Maybe. 28x. I just put the 28x in there. The 2x squared plus 4 to the 6th I factored out. I'm left with that x plus 4. And this is all over 2x squared plus 4 to the 14th. Don't you love these?
Where did the 14 come from?
This 14? Because it... The what? This one?
Yeah, you had a 28.
Oh, my bad. Thank you so much.
I noticed that too.
I'm going to go red, and then this will be 6x squared plus 12. And then minus... No, that's not 80x. It's 28 times 4.
Which is what I asked you. You said 8.
No, you said 20 times 4.
But I said 28.
28 times 4 is 2, 3, 1, 12? What is it? What's 28 times 4?
I don't know. That's what I asked you.
Okay, here we go. Ready? This is where I'm going to go fast. Here's that 5. Here I have x plus 4 to the 12th and multiplying by x plus 4 to the squared. So that's going to end up being x plus 4 to the 14th. X 2x squared, there. And then this, I'm going to have negative 22x squared minus 112x plus 12. I'm not there yet. Give me a second. This is all over 2814, so this will be 2x squared plus 4 to the 42nd power. That sounds like totally reasonable.
And you factor out a 10.
Here, these I have here and here, yes? So what do I do with the exponents? You subtract them. So this will end up being 2x squared plus 4 subtract 36. You're factoring out a 2, right? Can I factor out a negative 2? Sure I can. Negative 10, x plus 4 to the 14th, and then this will be 11x squared plus 56x plus, oh, minus 6. If you didn't factor out the negative sign, that's fine. But that's doable, yes?
I don't think I could freaking more Boston.
It's, there is a chance, I could have made this a little bit easier. Could I not have made this a little bit easier?
A little bit.
A lot easier. If at the very first step, if I would have made that x plus 4 to the 15th and 2x squared plus 4 to the 35th, would have been a lot easier. But I didn't do that. I didn't want to. I wanted to see if you guys could do it. Yeah. I just wanted to make sure that you're aware that when you're raising a power to a power, when you go to put these two things together here, you have to make sure that you take into account that power that it's being raised to. Alicia? Yes, fine. Yes.
If we were to do the 15 and
35th. Just do the quotient rule. You're going to get the exact same answer. And it's a little bit less work. Good? Okay, I'm passing out a review worksheet. So this review worksheet, this is my mindset for this. Ready? Your exam is in like what, a week and a half?
A week and a half?
Your exam?
Oh, yeah, it's about a week and a half.
So I am viewing this test as our reviewing for chapter 2 for the exam. Do we agree?
That's sad.
Yes? So I'm not going to review it again.
Oh my gosh, it's our final exam for you guys.
You're not reviewing.
Well, I mean, we're taking a test on it. You're not reviewing it yet.
Huh?
You're not reviewing chapter 2.
For the exam again? No. I mean, you can ask questions, but this. So, number 1 on the worksheet says find the derivative using the definition. That is not on the test, but it is on the exam. I'll say that again. Let's try this again. Maybe I'll be the only one talking in here. Number 1 says find it using the definition. You don't have to do that for the test, but you will have to do that for the exam. Okay? And I will tell you, full disclosure, because I like to be honest with you guys, there is one word problem that was part of your homework assignment. I'm not going to tell you which one, that will be on the test that is not represented on the review worksheet. Okay? Yes. Next class.
I think my calculator is